you know, I just learned today. Holden actually explained to me. So she's Spark committer. And do you know what a Spark committer is? Raise your hand. Who knows? Okay, so Spark committers means that Holden actually can make changes to Spark without getting any review. She changes the code, right? There are only 50 people in the world like her that can do these changes. And Luciano is a PMC. That means for SystemML. That means that he actually decides who is a Spark, who is a committer for SystemML. Okay, so we have two, experts, gurus here in the room with us. And okay, now I let you go with Luciano. Now that I've explained to you, this about this.
Gracias. Buenas noches. Voy a hablar hoje poquito sobre Spark Technology Center and Proyecto SystemML. Unfortunately, now is where I change to English. Otherwise, you guys are going to be hearing so many strange words. So I'm a data science platform architect in a Spark Technology Center. If you want to see me, contact me and stuff, here's the information. Also a member at Apache, and also a SystemML committer and PMC member. Basically have been there since when IBM was making the project open source from a research project into Apache. We talk about IBM, and I think we mentioned already some of the areas that we are contributing. And just to make sure, we and IBM have been doing a lot of things around open source. We are members and have a lot of committers at the Apache Software Foundation. We are contributing to many of the projects there, and not only there, but also in different organizations. We are member and founding members of projects like AmpLab, RiseLab, Scala, and many others. We also have IBM participating internally as open source user groups where we take information from you guys, learn what you guys want to see, the direction of the open source, and then the open source that we work on, we try to accommodate and listen to you guys. And one of the things that IBM did in terms of open source is that we embraced Spark, and we created the Spark Technology Center in 2015. And the idea was to basically make Spark ready for the enterprise, and then we started contributing there. Not because we were IBM, we couldn't just come and say, well, we're going to contribute to Spark and everybody's going to accept us. We had to really come from zero, as you can see here, and really gradually go up to become the second most contributor into the Spark community. With the time, then we start seeing we were in the community, we were recognized, and we started increasing the scope of the areas that we were starting to contributing. We start working on, and these are some of the project areas that we have started contributing. So in machine learning, we have, as you see, Spark ML Lib. We created a project called R4ML. Have been working on the Apache error integration, SystemML that I'm going to be talking here, deep learning, and others. For SQL, we have been doing a lot of enhancements there. As you see, as you know, IBM has a very big history in SQL, and in that area, we got some of the engineers that have been working on DB2 and other technologies that we had inside IBM, and we got them to contribute and enhance what we had in Spark. Also around consumability, we have been working with reference architectures. We have been working on the notebook stack and projects around that, around resource optimization, Spark Web UI, Apache here, which is a lot of extensions for Spark, data source and stream connectors. And various other areas that we have been contributing. So now let's talk about SystemML and try to give you guys an introduction to what it is and how you can start using. So how it all get started? This became as a project from the research team in IBM. And what we were seeing like in 2007, 2008, so a little while ago, everybody was kind of like trying to do something around ML. We are seeing lots of different groups doing different things. And what happened is in 2009, the IBM decided, okay, let's create a group just to work on dedicated to a scalable ML. And that's how we started looking into use cases and how like our basically clients and other people around were using and dealing with SystemML at the time. Oh, sorry, about ML at the time. So the pattern that we start seeing is basically like for small data. And by small data, I mean data that you can fit into a computer. The data scientists were pretty happy with that. They would usually just work on like something they were used to. And by that is a high-level algorithm, a high-level script language such as R or Python. He would have the data available there. He would basically work interactively, experiment until he finds that, yeah, that's what I want to do, that's what I want to learn, and get insights from data. And he gets the report, he gets the model, he gets everything, and that's done. So pretty well. But what we start seeing then is the amount of data that needs to be processed where it's starting to grow. And so the time that we couldn't fit that into a one system. And we need to use more resources. But then we start seeing that wasn't working so well. The data scientist, well, he still would work on basically R or Python and not really going to go into some like a low-level programming language or APIs to get his script ready. So in that sense, we will have to start involving a system engineer there, which will basically get that R Python code and try to accommodate, try to rewrite that, let's say in Scala, so that it can run, let's say, in Spark. And what we started seeing on that is that interaction, that basically giving the information, making the translation, trying to do some runs, and get the data or the results back to the data scientist, were not working so well. It was taking days, sometimes weeks, just to one thing. And then you will see that, oh, I misspelled a field name, or something very silly is wrong, and then you have to go rewrite and do the whole cycle again. So to solve that, that's how SystemML gets started. The idea about SystemML is that you want to do fast iteration, you want to have the same answer. You want to still allow the data scientist to continue doing the development on the areas that he's comfortable with, if it's Python or if it's R. The main things that are exposed in SystemML and what people have been using is basically linear algebra operations that basically you use that to basically come around and build your algorithms there. So it provides a highly optimized distributed linear algebra for the data scientist. Now let's take a quick look as an example, just so we can see how it really works, how things will play in SystemML. Let's take a look at alternating least square. I think the data scientists in the room will be very familiar with that. And one of the things that I did in the past was basically use that for movie recommendations. So for those that know, I think there was a data set from Netflix that provided a lot of information about likes on movies, etc. And I did an experiment previously for a different conference that basically built and tried to do recommendations from that. And I used ALS for that. The idea is that you build basically a sparse matrix with the likes that you have, and then you start using ALS to start populating more information, which will then be used for seeing how how likable it will be for other users. So basically, you start the ALS algorithm will start multiplying the factors. It will at some points hold users and get the movies and vice versa, and you will start basically seeing the new information being populated into the matrix. So how does that look like if you are building that like as an R algorithm? Very simple. This is the algorithm, the ALS, that you will do in R. And if we look, basically each areas of the algorithm has a purpose to exist. So you start with random factors, you hold the movies, and then you find the best values for the users. You do the vice versa, hold the users, find the values for the movies, and then you repeat those steps until you find convergence. And as you see, like every line has a purpose for that. So let's take a look at how this would look like if we were doing, as a system engineer, we'll be doing this, for example, in Spark code. And I think as Holden was saying, just to a little bit of demo that she did, she went through like many slides with Scala code. That's not different when we look into ALS in Spark ML. And yeah, this is the next page. One more. Yeah, so what we had in like 25 lines of like R code became all of this in Scala code. And you can see that you have a lot of room to get a lot of like errors or conversions problems that will get you in a very mad situation.
I'm still waiting for apologies.
So that's mainly for you. You said you're probably the only R guy.
Exactly, that's why.
But we'll see that we have similar things for Python as well.
No, that's true.
So going back to the ALS algorithm in R, let's take a look at like what it takes to basically run the same algorithm in SystemML. Well, there is no change required. Basically, if you're using basically linear algebra operations type of things in your algorithm, that will be supported in SystemML today. And we'll look more of like what are the optimizations and things that can be done on that algorithm so that you can run that in large scale. And then I think once I start looking to that, thank you. The first thing that I get as a question is like, okay, so we do this, but like how fast does it really run? And I know it's not like very good to do performance type of slides and stuff, because like you can have many equally valid answers, but we went ahead and did some experiments just to see how it would behave in this situation. We tried with 3 different data sets. In terms of the size, a small one which fitted into the computer, a medium one which was you had to go split to the disk, and a third one which was like very large. So when we run with pure R, basically we waited like 24 hours and it was still running. We said, okay, it's maybe gonna finish sometime, but we didn't have enough time to wait for more time. So when we started looking for, when we started applying that into data sets that didn't fit into the system, we started seeing basically out of memory because it couldn't handle that. We then we tried MLN just to see how it would fit, and we saw that for small data, very good performance. For medium data, it was still good, but because you start going more to disk, you start seeing decrease in performance a little bit. And when we tried with very large data, which really need to go in disk and disk, you basically, we waited 24 hours and we didn't see a response, if the finish. So we said, oh, okay, it's gonna take long, we quit it at that. We then applied for SystemML. SystemML and small data, I think Spark, the ML went better. And that's reasonable because it's very optimized. And when you're in memory, that's when Spark is doing the best. When we worked on medium data, we saw that SystemML did a very good performance to get the results. And when we worked on large data, we saw also that we were able to get all the results back within a reasonable amount of time. So basically some take points here. SystemML runs the R script in parallel. You'll get the same answers. It's comparable and it's comparable to a low-level algorithm that you have, and you're still like working on your high-level script language, as you see. How is that possible? Basically, I think as a SystemML, similar to like a SQL, but for machine learning. When you build SQL statements, you know that underneath that you have like an optimizer that will build basically a logical plan, will build physical plan, and those are very optimized, and they will never look like the same type of query that you did. And that takes in consideration the data size and all of different things to rewrite those queries to an optimized state. Similar, we have something for SystemML that will do the same. It will take our algorithm and we'll look into that, and we'll try to make critical performance decisions for you so that it can run, and it can run fast. It takes consideration if you're running distributed or local. And basically, if you have something that fits into memory, why would I go and do the shuffling and go all the way to different nodes? SystemML will optimize that. We'll try to decide how to partition data, persist or not persistent. Also, we'll try to build distributed versus local, try to build a hybrid runtime and do any optimizations that is needed. And there is more. It can do a lot of like optimizations, and the number of rules that are there for the optimizations has been increasing and getting better as we see different use case or patterns coming up. So this is a quick summary of like what SystemML can do for you. So code-based compilation of machine learning algorithms. It will generate execution plans. Out of the box, scalable machine learning algorithms. And you can also build your own as well. And all in a high-level language. The benefits that we see is like simplifies algorithm development, make experimental easier, even with large data, and your code gets faster as the system improves. As we see the runtime with new rules, or as we see new capabilities being added there, the same algorithm that you have and maybe was running like in an hour, it can start running much faster with the improvements that we do. In terms of algorithms, SystemML provides you a lot of like, we call it sample algorithms. They are really working algorithms, but you can use them as they are, or you can use them as a start point, so you can start tweaking to the insights that you want to take, or the problem in particular that you have. And this is a list. At the end, I have a link to where all the algorithms are available in the documentation in our GitHub. So you can access, you can see all of them, you can see details. And I'm also going to provide a quick tutorial, a demo at the end, on how you can start learning how to use them. So just take them for now as a reference. So let's take a look at what is new in SystemML. Lots of new functionality and things have been added to SystemML in the past few months. We have many of folks in the community working to different areas of interest, and that has been, I'm going to just describe some of the areas that has been progressing in the community here. We have made our Python experience a little bit more, let's say, more like production ready. And we took like the idea here to basically, it's like what we call like PyDML as well. We originally have the DML in R, we now have PyDML available. And you have also many APIs that you can start embedding and using those algorithms in Python, Scala, Java, and also we had, as I mentioned before, the R4ML project that gives you the same experience for when you're doing Spark R to start embedded and using those algorithms as well in Spark R. A lot of folks use scikit-learn. So we're trying to do a ML Learn API, which basically gives some similar APIs that you might be already used to because you're a user of scikit-learn, and then start using that into SystemML as well, and then basically supporting that. Here's an example. There are still a little type of things that you might need to update in terms of the full algorithm, but we're trying to minimize that and try to support the same APIs. Let's see. Also, for folks that are using Cafe, we created a Cafe to DML script that basically will take what you have written in Cafe and then basically create a SystemML script for that. Basically, does a port for you. Here's an example. We also start building. I mean, we have been talking about deep learning. We also start building support for that directly into SystemML. Mike, one of the colleagues, has been using a breast cancer use case to basically drive the APIs and drive some of the requirements into SystemML and how to and that's how we became, how we started building the deep learning APIs into SystemML. We also added support for GPUs. So I mentioned before that basically once your code, one of the benefits is that your code gets faster as the system improves. By providing the GPU support, and if you have the environment, the system that has that capability, you start seeing a lot of improvements on that area, and then to get performance improvements from using the GPUs. In terms of like how we are using the GPUs, we are providing support for a single node, multi-node, and a hybrid. The hybrid is still kind of like in progress. The single node and multi-node, I think we've won, and many GPUs are more available today and it can be used. And yes, just going back, so as I mentioned, GPU will accelerate algorithms without changing its code. Here are some examples of like the current status and then some speed ups that we got by using GPUs. About other things that are new, so we became a top-level Apache project a few months ago already. So I mentioned a lot of the API improvements, deep learning, code generation, and compressed linear algebra. We are also looking to get SystemML 1.0 release. That, from the discussions that we are having in the community, I think we are trying to get the first release candidate by first week of December. So if you guys are interested, you guys want to try, give it a try, take a look at that. I'll have pointers here for how you can subscribe to the community and be aware of all the things that are going on. Now let me talk a little bit of like Apache, a tutorial that we have built. And basically, if you are eager to start taking a look at what SystemML can do for you, this is a very good start point. We have provided, so let me see here, it should have been, so those links, it's okay, do I have to? Oh, okay. So the links that you see on the presentation will basically bring you to these two pages. This is kind of the entry point for the tutorial. It's you can have basically, let me point here. You can have access to the code, which is in the GitHub, and you can also see like a video that describes the use cases and all the information here. If you want to take a more detailed go through it when you're home. And there is a lot of information and requirements here. You can use plainly like in your, just like an Anaconda Python environment locally, or you could, for example, in my case, I want to just use cloud so I don't have to take all the resources on the machine. So a way, if you want to get the code, so you would get here, this gives you access to the GitHub. The way you do, you basically go to notebooks, you will see the Python notebook that is available there. And what I did is I clicked raw just so I can get the raw file, and I went to DSX and I just imported the notebook. So if I go to, so while I load here, just 1 second, I have to. Hopefully it's okay signing you up.
Sí, hombre, pero yo quería hacerlo con su exactly. De hecho, lo puede cambiar.
So, I guess you guys trust me that it will work okay. So basically, you can go into DSX, you can import, you can basically import the notebook, and the notebook, what it's going to give to you, so let me go back here. And it will explain to you basically kind of like I think 3 main areas. One is how you can start just using SystemML to create your linear algebra algorithms there. It will also look into like things that if you're just using Python or R would not work. Like for example, like you'll get like out of memories. And that by using SystemML, you had optimized code that will get those same algorithms working. And we'll also have sample APIs, sample cells on the notebook that basically let you start using some of the existing algorithm samples that I showed you the reference, but also how you get those if that don't fit 100% to your needs, and how you can customize and run those so that you have a custom algorithm available for you. How do I go back to the slides? Sure. We could, if you could. Yeah, you can just move it on. Just copy the URL. No, just the URL. And when you create a new notebook, so even better, we have like a live demo so that it tell you guys how exactly you guys can get it working. And basically, once you import, you can start running. These are some of the markdowns. You will see that SystemML is already available. The 0.15 is the latest release before the 1.0 that we are working on. And you can start seeing, so like as I was mentioning, just like how you can do just some like matrix multiplication, some linear algebra things. In this case, then it's like a NumPy example that with a very large matrix will start getting you out of memory. And then similar thing when we start doing with SystemML, you will start seeing the results. And many other, you can basically start playing, take a look, and start customizing using to your own needs. But here's like some data generation. We do some integration. For example, if you want to start plotting from SystemML, as I mentioned, how you start, for example, calling existing SystemML scripts that are available. And if you need later on, how you will then build your own script. You can start by using one of the ones that we have provided to you and customize to your needs, and that's like how you would do it, for example. And many more, and many other examples here. So it's a very researchable tutorial for folks that are just trying to get started. It gives you lots of examples. It's very easy, as you see, to like just from the source code to start getting it used and start playing with that. Again, these are the links. If you don't have a DSX account and you want to create one, that link I think gives you, to a certain extent, some free time or free account there. For the folks that are interested, I mean, as we are learning more, so here we have a lot of information. So the website from the Apache SystemML project. There are references for papers. We won the best paper award for the compressed linear algebra in 2016 at the LDB. We also have like other references here that you guys can use and learn more. General references in terms of like where to find our code. Some of the references for like DMLR. The algorithms reference, the one that I kind of had a summary there. You can go to this URL and you can see all the ones that are available there. Sometimes we have, we have more than those, and we have some slight different versions of the same algorithm. And also like more runtime references here. Okay, that's about it. I'm gonna make the presentation available in my Twitter account, and also like a slide share, so you guys can have that. And anything, I mean, we are open source projects, come helping us. Subscribe to the mailing list. You can ask any kind of questions there. We have folks that are basically watching the mailing list, and then they'll be very helpful and eager to answer the questions that you guys might have, and anything, just let me know. Thank you very much.
So, bueno, he pasado a español.